Okay, we're ready to program our PusherBot, this time with an arm. So it's a little bit more challenging than before because we actually have these arm motors that we have to control, and then we're going to actually create a couple of smart keys on your controller. So the first thing we want to do is add an arm group or a motor group. So we're going to click on Add Device, and then we're going to do Motor Group. And then we had motors in ports 8 and 11, and I'm going to call these arm motors. And then I have to reverse one of them because they're mirror images of each other. So when you put motors mirror image, one of them needs to be reversed. And I'm not quite sure which is which. So I just usually do the second one as by default. And then I'm going to say that this is up and this is down, so that when I'm controlling it, this direction is up and this direction is down. Instead of doing forward reverse, that means nothing with an arm that moves up and down. So call them up and down and then hit done. Now, when we program this, if our arm is going the wrong direction, all we need to do is just flip these. So we reverse the 8 and normal the 11 if it's backward. So we'll do some testing and make sure that that's not the case. But here we go. Now we need to go back to controller, and we need to make it so that we can move that arm up and down. So I like to use the shoulder buttons. So that way I can keep my fingers on the joysticks, and I can use the shoulder buttons to move an arm up and down or open and close a claw. So I'm going to use the right arm motors to move up and down, or the right shoulder button to move up and down. And you can click this if you want to reverse those. So up is the lower one, but again, up to me is the upper one and down is the lower one when I'm driving. So that's what I need to add. And then a couple of things that I need to add in terms of code. I need to set the arm motors velocity. So I want them to go at 100%. I have a gear ratio on there of 5:1, which slows the motors down already, but gives them more torque. So that's why we did that 12-tooth to 60-tooth gear train, is so that it's got 5 times the power with that gear train, and then we're using 2 motors. So basically this motor group is 10 times stronger than a single motor by itself, is why we do that. But we can spin it 100%. It's not too fast. We're going to set the position to 0 degrees. This is important for some of the things that we're going to add to our program. So when we start our program, we want our gate to be all the way touching the floor. So every time we start the program, when we're ready for a match, we push the gate all the way down, and then we start our code. That now establishes that the ground is at 0 level, because I'm going to put some pre-programmed buttons that will raise that to a couple different heights. So I don't have to try to guess and get there with my 2 joysticks. I can push a button with my left finger, either the L up or the L down button, and it's going to bring that to a specific height. So if I've set that as 0, I can then establish different heights because the motors have built-in encoders in them, which is a really cool feature that this will do. The other thing that we need to do is set our stopping. So there's 3 options for stopping motors. You can either coast them, which means they'll just kind of coast to a stop. So imagine like running an electric motor at full speed and you cut the power. It doesn't immediately stop. It'll keep rolling for a little bit. Brake will send a voltage in the opposite direction for just a little bit of time. So it actually will like do a jerk stop. So like, and then jerk stop. That's great for moving your robot autonomously. Brake is a good one because you want to stop at an exact spot. Hold is used for any arm or claw that you want to hold a position. So for this one, because the weight of the arm is the arm has weight, it's going to pull on those motors, and over time it's going to sag. And if you were to lift something that's heavy, it's going to droop over time. So what the hold feature does is when you stop the motor, it looks at the encoder value, and then it will maintain that encoder value on the motor. So if it starts to drop, it will then increase the velocity to then actually hold that position. Or if you're trying to lift your whole robot off the ground, at the end, it'll hold position, and it'll basically like keep sending a voltage to those motors so that it will then stay off the ground. So that needs to be set to hold. I did my driving stop to brake. And then I have 3 controller commands. So let's look at these. So when you press the L down button, it's going to spin the arm motors to a position of 20 degrees. So like I said before, 0 is the ground, 20 degrees is just off the ground. So if you push that left shoulder button on the bottom, it will then, so this will then bring it to a position, no matter where you're at. If you push that button, it's going to go zoop and go to there. If you're down low and push it, it's going to go to there. We're going to do the same thing for our L up button. 360 degrees brings your arm about this angle. So 360 is of the little gear, which is only 1/5 of a rotation of the bigger one. So if you take 360 divided by 5, you get roughly what, 70 some odd degrees. So you're basically going to go up to a 70-degree angle with your arm when you push the up button. So basically you can open the arm up, or open the the opening. And then finally, if you push the F up button, it's going to spin to 900 degrees, which is going to bring it all the way to the back. And this is how you hang on the bar. You can literally push one button and it will bring the arm all the way back around, so it's hanging off the bar. And these are under events, and you do when controller button is pressed to do those events. So get that done, download it to your robot, see if your shoulder buttons cause it to move up and down. If not, you're going to need to adjust your arm motor positions here. Otherwise, you should be good to go. Good luck.